Okay, hello everyone. Good afternoon. Things a little bit blurred. Maybe. Okay. Before we continue the sections, I will just remind you that we have discussed the introduction, just naming the order in differential equations, and then we get to know the what kind of solution we have, right? Because the difference between this engineer of math, particularly the differential equation, is that when we deal with the calculus, we differentiate, we integrate, we want to take the solution into one exact answer usually. But now, in differential equations, we get to know the at least family of solutions, and to restrict the answer, to make it precise, we usually have, we call the initial value problem, like this one. So we have the equations, which is its differential equations. We have the y prime here, and what we are going to do is we need to find how many curve that fits with this differential equation. Which we are usually in calculus, we usually differentiate, and that is our answer. But now we already have the differentials. What we are going to find is the possible value of y, the curve itself. If we just want to know the y, because at the end we are going to have integration, we already learned the separable techniques, which is actually we are going to separate each variable, okay, each independent and dependent, and then we integrate just as usual integrations, okay, and we get finally our predictions. We get the tangent inverse y is equal to negative 1 over x minus x, and then we have a constant. And we have a constant. Okay, and this constant is sometimes really problematic, so we need to make sure that our solution is on point. So we need to have our initial conditions to make sure that our curve is just one curve, because this constant can be any constant as long as it fits the solution. Right? Okay? So that is a typical problem in the first order, or in more general, I think in mostly general differential equations, they will provide you with some initial conditions. If not, then you can just add and up until here. Okay, this will be your answer if you're not given the initial conditions. Okay. Okay. So that's and then we also have the integral defined solutions, which means that you are having the integrations that is non-elementary. It means whatever method you try to make, you cannot integrate easily the function. For example, the function of e with power of negative x squared, you cannot do anything. Okay, you just stop, and then the final answer should include this integral. Okay. So how do we solve and try to make in the differential equation? We need to include the third variable, the dummy variable. Like in our calculus, we usually use this dt with the fundamental theorem of calculus, if you remember. The same thing here. We try to separate this equation using separable technique, and then both sides integrate. And for the right one, just stay as the integral form, and that will be at the end. That will be our final answer. Include this integral form. Okay? That also can be choice of your answer. Okay? Well, you can do some approximation, but I don't think it's going to be helpful. But I think you can just stop here, okay, to make your life getting more difficult. Okay. Another thing that is important. I think I have mentioned the autonomous order differential equation. So whenever you find any for example, any dy over dx, for example, the equations will only have this y. Okay. This is called the autonomous order, right? One example. So whenever you find a function that only has this dependent variable, and there is no x, right? So when you have this, you can predict how the curve will behave. You can draw like a line number. So you can imagine like a line number, but it's for y. So instead of horizontal, we draw the line vertical because it's on y. So we take this. And then we try to make like a critical point in our usual calculus problem. But here we call it same critical or equilibrium, but now it's for y. We can say that y is both of these numbers. So we can write down. Let's say 2 is there, negative 2 is here. And then we check, right? We check with the interval. But we start from the top. Maybe 3. If you put 3, it's positive, right? Positive. Let me just write positive first. Positive here. And in our case here, what do we do when we have positive? We draw arrow, right? We draw arrow upwards. And then plug in maybe 0. What is 0? It's negative, right? If we put 0, it's negative. So if negative, this is going to be down here. And then if we have negative 3, what will happen? Is it negative? Is it negative, right? So positive. Okay? So positive like that. And now we have in this is called the phase portrait, just a review. This is called the phase portrait or phase line. This is the other name. And from here, it goes up, goes down, so they are going far away. They are repelling each other, right? So they are not stable or unstable. Okay? We call this unstable. So this part here is make what's unstable? Okay? What is it? The stable or unstable, it is referring to the asymptote here. So if you draw your slope field, remember before we go in here, we can draw the slope. Just put some x, some y. Draw all the points, maybe from 0 to 8, 0 to 10, and you will see at y equal to or y equal -2, there will be a horizontal asymptote. Okay. This unstable, you will see when we move out the curve, you will see there will be some issue in stability. Okay. Okay. Now we have the arrow downwards and the arrow upwards is going to one point. We call this the stable. Stable. So in asymptote is called the stable, because you will see that this is going to be the curve is going to nearby every time they near this negative 2, they will going to be closer and closer to the asymptote, which is stable. The unstable is going to be far away from the asymptote. That's the characteristic. But what is important, this autonomous order in our equation here, this is related to what we deal with the separable techniques. So if we try to separate this, we want to separate this. So for example, if we want to separate this, let me just write here. I can write this, make all the variable y on the left side, okay? And make just dx on the right side. Okay, there are several ways to finish off our techniques here, but I think the most possible, if you have a fraction like this, and you want to integrate, right? You want to integrate this, is to separate the fractions, right? And later you can have the ln, right? If we see this as a factorizable form that is having y minus and y plus 2. I hope you still remember the partial fraction. So we can take this, okay, into, let's say plus, and let's say this is a, b, and do the partial fractions, okay? But I will skip the process. I hope you still remember. I will give the ab. So a is 1 over 4. And b is negative 1 over 4. Let me just put here. This is y plus 2. Oh, I forgot dy. So this all multiplied with dy and equal to dx. Okay, I think I need to copy all this. Let me copy. And we move to the next page so it's much clearer. Okay, I think we can just cut. There. Paste. Okay. Okay. And then we take the integral. Okay, we take the integrals. Let me just take integral. But what does integral doing here is we are going to integrate each of this fraction, right? So this y minus 2, we integrate become ln, and this is just a constant. So we will have a 1 over 4 ln, right? And then negative 1 over 4 ln. Okay. And then x, and make the constant goes here. Okay. Remember that in every integral you need to plus a constant. But here's the thing, okay? You have a constant on y, you have a constant on x. My suggestion is always add the constant on the right side. Although it will be possible if you just plus constant here also, but at the end they are all constant. And if you want to some consistency, my suggestion, just plus at the right side. Okay, let's say it's C1, okay? And then simplified, maybe multiply with 4, and then combine the logarithm, combine the ln. So ln, this will be y minus 2, y plus 2. And then this will be equal, and because multiplied by 4 will be 4x. And it should be 4c1, but let me just change to another constant, c2, okay? It's the same constant. We don't really care much actually at the process. We really care at the end when we find the initial value. Usually we compute the constant. But now let's just say it's c2. Okay, let's just simplify it and make it into y forms. So we use that. Okay, so this will be y minus 2, y plus 2, and e with power of 4x plus c2, right? And remember, this e power of constant is just a constant, right? So we can actually change that into another constant. So e, let me write here. So e with power of c2 is, let's say, just a constant. Okay? So actually we can write this as e with power of 4x and then multiply with the constant. Now we can try to make the equations more clear. I think we can just multiply here and then some sort of steps, and we will find that the y will equal to 1 plus c e with power of 4x, 1 minus c e 4x. Okay. Now what's the deal with our calculation here? This is just to show you that from the previous autonomous order that we get, we find that the critical point is 2 and negative 2, right? So if we make this solution as our solution, we might forget something. Okay, we might forget something. So if you remember, let me write here as a notes. Okay, notes. Consider the dy over dx is so the critical points is negative 2 and 2, right? Okay, now, so we know that the answer is, the critical point is this one, right? That when we put into equation, that will be made 0, right? But if we look at this y, imagine any possibility for any x that can be, and maybe for any y that is in our solution there. So if you want to make y equal 2, so imagine this y is equal to, I think if we take this into probably some value that make this into a constant, I think it's possible to make it 2. But can it be negative? Can it be negative 2? Can it be negative? Can it be negative? So, for example, if we take this constant 0, it's precisely y equal 2, right? But can we make it negative 2 for any possibility? I think it would be difficult, right? If we were to make it negative 2. So that's why the important thing here is whenever you find the differential equation, before you try to find your, maybe using the techniques, the separable, like really long here, eventually, if you can make this observation, you need to do this first. Then you know that, oh, this y, if we put in, it will be negative 0, which is, we call them the singular solution, right? The singular solution, if you remember. And when we already made some suggestions to the separable techniques, one solution here is not easily get from this part, right? That is also one thing to consider, okay? When you try to make up the solutions, remember that there will be always, not always, maybe mostly there will be some singular solution. What is singular solution? The singular solution is usually, when you put in the solutions, it will be a 0. It will be a 0. Usually a 0. So Or you can say that the singular solution is a solution that is outside of all of your techniques. Okay. But when you plug in the point, you will get the same conclusion. Oh, this is also a solution. So you call that a singular solution. Singular solution. So let me write here. So don't forget singular solution that might, let me just write loss in your calculation. Loss means when we have this, we don't really think that it can be negative too, but when we go back to the original equation, it should be that has this too. Okay, I think after this page, I will give you an example. Okay, example, and then we move to the next part, the next technique. So this part, the whole part will be, it's called the separable techniques. Idea is you find an equation, you can separate the variables. You put one variable on the left, one variable on the right, integral. Okay, it's always like that. Okay, maybe giving you the example. Okay, two questions, two example. I hope it can help you. Yeah, you can try, and maybe I hope this can refresh some calculus. So my plan until the end of September, I think we can just continue the first order, try to finish it. But I think in the first week of October, maybe we'll have a quiz. Okay. First week of October. So now, next week still continue. And maybe next 2 weeks, maybe the quiz will be on Thursday. I think it's okay Thursday. So the Tuesday will focus on the content. The quiz will be the introductions up until the first order, the last techniques before the quiz. Last technique before the quiz. So this one separable, maybe linear, and maybe after that we have another technique, maybe 3 or 4 techniques. The first order. Now after the quiz, we continue finishing the first order, and then maybe going to the higher order. And after that, I think last October or first week November, that will be the midterm. Okay, so try to solve the equation, the differential equation. After you find there is a constant, find the constant for this initial value. Find a constant, and then that will be your answer. The same thing, the second one should be similar, but there will be some differences that I need to emphasize. Because what we have done in examples, the solution is always in a really precise curve, like y equals something. I want to show you that we can also have what we call the implicit solution. You will see later on. You will see. Okay, so the idea of separable techniques is just like the name. You need to separate y and x. Okay. Now, of course, all this example here is a separable one, so it can be separable. So first, we start maybe from factoring the y on the right side. Okay, and then you will see that we can move out this y to the left, and this x to the right, right? So let's just doing that. So 1 over y equal 1 plus. Okay, now we have a fractions here. I think we can just separate this. So we can 1 over x and 2x, right? So we can write, oh, where is my y prime? It's gone. I forgot to write here. Okay, so 1 over y prime, and then 1 over x plus 2x. Okay, and now we take the integral, or if you would like to make sure this is the y prime is dy dx, so I can write this as dy and then dx going to the right side here. Okay. Okay. Now 1 over y is ln, so we can write ln y, and this will be ln x plus x squared plus constant. Okay, now to solve this, what we need to do is we need to find constant. So we use the initial value, which is 1, 1. So because we have this, then we plug in 1 and 1 to the x and y. So this will become 0, this becomes 0, and this become 1, right? So C is negative 1, right? So from this C, we can complete our equation. Let me just write here. Ln y is ln x plus x squared minus 1. We can make it into e to erase the ln for y. So we have y e. Let me just write completely here. And I think we can erase the e ln with absolute value x. It's the just absolute value x. And then e I think we can stop here, right? We can stop here. Okay. Okay. Okay, any question for the first one? Okay. Well, to check, you can derive the equation and find out the y prime. Okay. Yeah, hopefully it should be the same, right? And I think it should be the same because when you derive, this x squared will be going to be chain rule, right? You have the 2x and then we'll be multiplied with x, so 2x squared. So that will be this terms, and then it will be having a product rule, and the other one will be this y that is the. Yeah. Okay, the second one. This one. Well, it's I think a little bit easier to integrate. Not really need any elements, right? Just a normal integrations directly. Okay, but maybe we can solve together. So again, we separate the y and x. And then we just integrate. So this will be 1 over 3 y cubed plus y equal 1 over 3 x cubed plus x plus constant. And we will have the conditions that is when x is 0, y is 1. So x is 0, y is 1. So 1 over 3 plus 1 equals 0 plus 0 plus c. So c is 4 over 3. So this will be 1 over 3 y cubed plus y. And then plus 4 over 3. And actually, you can just stop until here, and you can say that this is implicit solution. Okay, you can just say implicit solution. So what's the difference? The explicit solution is precisely y equals something, the dependent variable will be having the equation precisely on exactly that single variable. So we could say that this is implicit solution. We can say this is implicit solution. So we can just stop here and we can just say, okay, this is our implicit solution. And this one is, we say, the explicit one. Okay. Maybe this week I will maybe prepare some question for this homework. Maybe around Friday I will post on Moodle. Maybe Thursday night or maybe Friday morning. Okay, so after this part, we'll move to the next topic. Okay. Any questions before? I think it's okay, right? The techniques is supposed to be easy to be completed. Okay, so the next part. Oh, this is my example here. Okay, the same. Okay, let me write. The next sections is we call the linear. Let's just say linear equations. So the next part is linear equations. So linear equation when the order is 1, the first order. Okay. Let me write the general order for linear. So this is called the linear equations. Okay? So this is called the linear equation in dependent variable y. Okay, some definitions. When g of x equals 0, linear equations is, we call the condition is homogeneous. When g of x is not 0, it's not homogeneous. We will understand more about this homogeneous, not homogeneous later, but let's just say this is the definition for now. Okay. Okay, now from this linear, okay, we would like to have a more simplified equations that may be more useful in the future. Because we have a constant here, constant also here, we have a function of x here. So maybe we need to divide by either of this a1 or a0. Okay. So let's just divide by the a1. Okay. So let's divide. So let me the arrow divided by a1 of x. Okay. So we will have dy over dx, and let's just say a0 divided by a1 is another another function. Let's say it's function of p of x, okay, y, and then equal to, let's say it's function g, but let me just write with f. Okay. Now this is we call the standard form of linear equation. Now, to try to make out our techniques, firstly, because we have this homogeneous and non-homogeneous in our solutions, so imagine that if we have this dy over dx plus p of x y equals 0, okay. From the separable technique, we can find out easily, right? We can find maybe some y equals something as our solution. So let's say the solution of this is we call the yc. Okay. Let's say suppose yc is the solution of homogeneous. Okay, so let's say we have the yc. Okay. So if we have this f of x, then we will have some solutions that will include this yc also. But there will be another one. So suppose y equal yc plus yp is a solution for the differential equations To prove this statement, we can just take some time to these solutions. Okay. So let's derive this. Let's derive as usual. So yc plus yp or let me just write here. We have dy over dx plus p of x y equal of f of x, right? Okay, now we plug in this y. Y is equal to yc plus yp. This yc plus yp put here and put here. Okay. So this will be going here. This will be going here. Okay. So d dx, and then we put in yc plus yp, and then plus p of x, and then this will be yc plus yp, and then equal of f of x. Or let me just write the computations first. Okay, let me just compute this to the right. So we will have dyc dx, okay, dyp dx, and we have px yc, px yp. Let's just separate them and then grouping all together yc and yp. Okay. So the first here is dyc dx plus px yc, okay, plus dyp dx plus bx yp. Okay. Now what's interesting on this yc and yp, because we know that yc is the solution when it's homogeneous. Homogeneous is when this is 0, which means that this will be 0. Okay? This will be 0 because of that is homogeneous. So this will be 0 because of homogeneous. And this part here is perfectly our solution for this f of x. Right? So this is perfectly equal our solutions. Okay, now from this fact, we can then write. Okay, the definition is quite long, but the summary will be very short. Okay? The summary will be very short. Okay, the non-homogeneous one. Okay, the non-homogeneous. Let me write, or the homogeneous. Let me maybe let me write in the next page. In the next page. So remember the homogeneous. We have dy over dx plus p of x y equals 0. And somehow, because it's equal 0, we can rewrite this and make it dy over y plus p of x dx equals 0. Now, of course, if we want to integrate this, there will be some ln, right? And then we will have some e, right? The exponent, like in the previous examples. So let me just write the summary here. Solving homogeneous will gives the solutions for yc is equal constant e with integrations of dx dx. Okay. Or we can simplify this yc as cy1, and y1 is e I think we can have a break for a while. Okay.
lihat yang saya sebelumnya nggak?
Yang mana yang ini?
Iya, saya belum bisa lihat tadi.
Iya, boleh.
Ini linear kok nggak boleh ikut ini, kalau linear kan nggak boleh gini, kenapa?
Kenapa?
Kalau ini kan linear, terus kalau ini katanya nggak boleh linear gini, kenapa? Kalau ini bukan linear, kenapa?
Kenapa? Karena ini tuh sebenarnya mana sih judulnya, mana di judulnya? Ini nih, nah karena dia itu kalau misalnya apa namanya ada dua komponen yang sama-sama variabel Y, dia tuh yang murni linear itu dia harus berdiri sendiri ya. Karena kalau misalnya dia dikali di situ berarti kan dia ada pengalinya, jadi kayak ibaratnya kalau kamu Y dikali Y sebenarnya mirip seperti itu. Dan kita melihat si linear kali itu cuma Y doang ya, kalau X yang lain.
Yang saya kemarin kok bisa aku hilang.
Yang mana sih?
Ini yang kemarin yang tadi itu yang eksplisit.
Oh iya.
Itu aku hilang.
Ini sebenarnya pilihan sih, kalau kita udah bisa memastikan setiap pilihan itu apa ya? Karena kan dia juga sebenarnya dua. Salah satu aja absolute kan nggak naruh. What are you thinking? What did you think? Drink responsibly. Well, 18 cans to drink responsibly. But then after you started doing it, you were like, were you there when you raised on space? Okay, let's continue. So for this proving part, there will be a little bit circling around, but later on the summary of this all proving will be, I think, very straightforward, and I think it's very very practical in the techniques itself. Okay, so let me continue here. So to see that we have now this y1, okay, and then this procedure, we are going to continue to, we call this as a variation of parameters. So So the basic idea here, we want to find this yp. Okay, now yp. We need to find yp equal to u of x, y1x. And we know that y1 we have e. So we can write yp is u of x, e to the power of negative p of x dx. So we want to make sure that this is a solution of the dE, the linear dE. So we are going to, let's say, to make it easier, let's just say this part we are going to make it just y1, so u y1. Okay. And then let's put into our differential equations, and then we just compute. So the differential equations is, and now we are going to plug in this y. Okay. So we have d dx. This will be u y1 and plus p of x. This is also u y1. Okay. Now this both are, they have both variables. So we are going to have a product rule for u and product rule for y. And we are going to group all of this u and y1 and u and y1. We'll group each u and each y1. Okay. So we are going to group together. So we are going to have u. Let me just product rule first, so you can see the results first. So plus y1 du dx. Okay. And plus. Okay. And we group this u. So this becomes u. And equal f of x. And remember that this part here, this y1, is part of our homogeneous one. So you can say that this is equal to 0. So we know that this is going to be the final conclusions, that we get the y1 du over dx is equal f of x. Okay. And again, we separate with separable techniques. So we get du is f of x over y1, let's say f of x, also of x, and then dx. And then integrate. This will be u is equal integration of f of x . Okay, and from the definitions we have at the top, this y1 here with e, let me just put here, from y1 is e if we take the 1 over y1, this will be a positive. So yp uy1 as our definitions, this will equal, the u will be this part. Okay. Probably you are wondering, where are we going now? Okay. And y1, you can take y1. Let me put the bracket here, and y1 is e and y1 that is inside here also change to this part. Okay, so we are going to have integrations, or let me put the e negative px dx on the front, and then the integrations of e integration px dx, and then f of x, and then dx. Okay, this is yp. Now the full solutions will be yc plus yp. Yc, as at the previous sections, this will be equal to ce and then plus e and then integrations e Okay, now what do we have here? Okay, what do we have here? Now we have this e with something over here, e something over here, something over here, and what does it mean in our method? We call this e as our integrating factor. Okay, we can multiply this. Okay, imagine so this part. Okay, we are going to multiply. This is negative, right? To make it cancel, we multiply with the e positive, right? Positive power. We need to multiply. So let's multiply. So multiply with the e dx, okay? So we will have the y multiplied with e, and then we can ignore this part, and then we can cancel this, right? So we will have e with power of integral px dx, y equal c plus integral e px dx f of x dx. Okay, now this is the conclusion. This is the one that you need to at least know. Okay? If you think that this part a little bit blur or maybe not really useful, I think I can tolerate that. But this part is important. Okay, I will copy this to the next page. Maybe if you want to write a little bit more, I can wait for a moment. So the idea here is actually you have a constant here. Constant is sometimes you can ignore if you want to derive because it would be a 0, right? So you have something here and something. So you have something that is e, and you have a y. It will be related to what would be the form before this, and then you differentiate, and it will be here. So imagine like a product rule, right? A product rule. I will show you. Okay, I will show you. Like a product rule. Okay. So let me differentiate it. This e differentiated becomes c becomes 0 and integral becomes removed. Okay, now let's take the product rule. The product rule we take, the first is this, and then plus e. If we differentiate, we have the integral on the top. This will be chain rule, will be px, and then e. We still have that, and then y, and then equal e px dx f of x. Okay, if we divide or multiply with 1 over e px dx, this will cancel, 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 and you will see that this is going to be our original equations, right? So the idea is, this is our question, right? We need to find the y. So what we are going to do is we need to multiply this, all this section here, with this e. This is what we call the integrating factor. So this is what we call integrating factor. So all this e is called integrating factor. So what we're going to do in this technique is basically from here, we multiply all, and from this multiplication, we need to make this form. We need to make this form. When we have this form, when we make like this, then it's easily to find this part here, right? Okay. It seems very complicated because of this form E, right? But in reality, in practical, it's going to be, let's say, if the linear is not really complicated, it will be very, 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 very fast, the techniques. So I think I can give you some example. For notes, this integrating factor, sometimes in your book, different books, different symbols. Sometimes they are using the mu like that. Sometimes using r. Well, basically they're the same thing. Or maybe what else? Yeah, I think I just found it r or p. So you maybe find another resource maybe from YouTube or maybe another books. They will have different symbols, but they mean the same thing. They mean the integrating factor. Okay, example. I will give you one example and then give some notes and then maybe another example. So solve y prime plus 4y equal e with power negative x. And then the initial conditions is y of 0 is equal 4 over 3. Okay. Now the first thing is just to remember the form, the linear form, which is the dy over dx plus some pxy equals some function of x, or g, f, any function of x. So this is dy over dx, already matched with our standard form. And then plus 4y, it has 4, we can consider this as our px. And then this will be our function of x. So we can consider that this is matched with our descriptions, dy over dx plus px y equal function of x, like that. Okay. Now the technique suggests to compute the integrating factor and then multiply to all sections here. Okay. So we write the integrating factor e with power of p of x dx, and in our case here, our p of x is 4, so we just plug in 4 and then integrate with dx. So 4 dx becomes 4x. Okay, so we will have this e with power of 4 dx, and this will be equal to e with power of 4x. Now, my suggestions, maybe you are attempting to plus a constant here, but let me just show you that because this e and the c will be a constant, so we will just take sometimes, maybe just take all the constant at the end. Okay, that will be useful. So let's just use this e with power of 4x to multiply with this equations. Okay. And then, so here is the compute the integrating factor first. The second, multiply dE with integrating factor. Okay. So let me multiply with different color. Now what's next part? Next part, if you remember what we have here, from this, we need to make out our product form before it's going to be expanded to become the product rule. So, imagine that this is the result of your product rule. So you need to reverse this into the product form. So basically what you're going to do is, imagine that there will be like a bracket here, okay, a bracket here. So you need to predict what will be the components here from this possibility. Okay. Of course, you will have the e with power of 4x, and imagine if you differentiate this, we will have a 4, which is 4 here, right? So you can see the correlation between this. This 4 came from here. You differentiate it, right? This y prime came from this y, and you differentiate on y prime. So like that, just you can for like to start the product form, you can try any forms from these possibilities. Maybe e4x, y, and then try and then see the correlations. And if you have proven that it's correct, then that will be your product form. So let's just try. Maybe e4x and just y. So e4x and y. And imagine it's like a product rule. e4x, y. The first thing maybe I will differentiate y, become y prime. So I think this part, right? And if we differentiate this e to the power 4x, we have 4e4x, y. I think it's correct, right? So I think we can stick with this one. And this part, we can just write this as, we can just cancel and e power of 3x. And now, what we are going to do is we need to remove this d over dx. So we are going to integrate, and you will see that you can directly get the y, right? The equation. So integrate this, integrate this. Okay. Oh, sorry. Y is here. And the integrate of e power of 3x will be e of 3x over 3, right? So then this is a constant here. And then y is, we can divide with e power of 4x. So we will have e negative 4x or we can write 1 over 3 e minus 4 plus 3 is minus x, and then plus ce negative 4x. But remember, I think we can have the initial value, which is this. So y. So this will be 4 over 3, 1 over 3, plus, this is 1 is constant, so constant will be 1. So the equations, by the end of the computations, this will be y plus e negative 4x. Okay. Maybe giving you a different example. Fine. Okay, maybe giving you one example, and I would like to see how you work out on this example. Let me give you a little bit complicated, just to exercise. First, we can match the standard, and then using the integrating factor. This 3x squared, right? 3x. So we can start with maybe writing the standard form, okay, so that you can more familiarize with these techniques. This is p of x, y, and then f of x. So we'll say that this p of x is 3x squared, okay, and the whole f of x will be this. Okay. So then the first one, we can compute the integrating factor, or the mu. Can write this, and our p of x is 3x squared dx. Well, integrating this x squared becomes 1 over 3x cubed. So we will have x cubed. So e x cubed. Now this ex cubed with e with power x cubed, we need to multiply to all components in our equations. So we will write this and then plus and this also multiply with this. Oh, I think the question should be having this cube. Okay, sorry. So the answer will be nice. Okay, sorry. If not, then you will confuse on the integrations. Okay. Okay, so we can cancel this. Okay, very nice, right? Okay, sorry. Okay, so if it's cubed, then we can cancel. Right? And then we can think how to make the product format. I think we can see the correlation between the ex cubed and this 3x squared. Right? Because when we try to derive this, we have the chain rule, and this will be 3x squared. So I think we have some correlations, and as I mentioned previously, we can just trial and error. We can try some components and then check the product rule. If we can differentiate, then that will be our product form. So we can write down the product form. That is probably the ex cubed and y. And I just take some time to check this. If we differentiate, we count this and multiply with y, right? And if we differentiate y, just y prime, and multiply with this e. And is equal to sine x. Then we take the integrations to remove the differentiations. So this will be e x cubed y. And sine becomes minus cosine x. And then plus a constant. Now we can apply directly the conditions. Condition is y0 is equal 1. So we plug in x equals 0. So this will be 1, negative 1 plus c. So c is 2, right? So we will have y. Let me just divide with e with power x cubed. So e negative x cubed. And then this will be plus 2 minus cos x. Okay, and of course, all the techniques that we have, the separable, the linear one, you need also to consider the interval. It can be, you can imagine the domain. Just to imagine how the solutions will be. Usually, if the question is asking like very specific one, like maybe to observe whether the solution exists or not, then you need just to verify. You can just verify. If there is some contradiction, then maybe it's not exist, or maybe there is no guarantee that it exists. But mostly, if the question is asking with some restrictions like this initial value, as long as it's consistent and it's logical, it makes sense, I think you can just stop it here. That is one thing to remember. And also the singular solutions. The singular solution that it probably will be still there, and you need to figure out. And usually it makes the whole equation makes 0. So that will be your singular solution. It will not be appearing in your techniques. It will be like when you try to plug in some number, and maybe that will be your singular solution. That is another thing. Okay, I think I will just stop until this part. Okay, we are going to maybe take more example, and also there will be one more about the piecewise linear differential. It can be also described in piecewise, so we can make several functions. So this f of x, the right part here, it can be like several ways according to interval. Okay, according to interval. Okay. Okay, I think we can go to our feedback time as usual. Let me check the this one. So hopefully it's okay. Sometimes using iPad, it's sometimes not really stable, but I hope it's okay. Only two questions. Just to make sure. Okay, I think we can start. Let's check. Okay, please use your ID, okay, student ID, so I can easily make score. Okay, ready? 3, 2, 1. I hope the time is okay. Around 1 minute. Half. So the question is, which one is the separable? Okay. So you need to remember what's the property of separable. So maybe you can try to separate. And the one that can be separated, that will be the answer. Okay, 50 seconds. I'm giving you like 1 minute half, but maybe if I give it in a quiz or in midterm, you have more time. This is just exercise. The last one is you can separate the E, right? Okay. Who is crop? Who is crop? Who? The first one? Who get the first one? Okay, good. Okay, last questions. Last questions. You solve the initial value. I give you 3 minutes. 3 minutes. I hope enough. I hope enough. You can separate, right? You can separate. Or if you would like to try the linear differential, the linear one, I think also possible. But I think you can separate, right? You can separate. Or you, because you already have options, you can have the other way around. If you would like to try. Okay, I give you a clue. There's also possible, right? Sometimes when I have the national exam in my country, that is one way I did it. If I get test, I give the option, then try from the option. There's another clue that when you look at it, you can see clearly correct answer. And it will, if you see it, maybe it can be done in seconds. I did some mistake that if you probably see where is it, and you will find the answer. How many solved? 12, okay. 24, 23. Okay, 15. And 9. Okay, that's okay, that's okay. Yeah. You know, you can try to plug in the points. Try to plug in the points to the options and then confirm it to the equation. That's one way. Instead of separable. Okay, congratulations. Okay, congratulations. Okay. Okay, write your ID and if you have any suggestions. Okay, if you have finished, then we will end our class and see you Tuesday.
gimana sih untuk nentuin ini? Untuk yang dari kan ini produk dari
Sebenarnya coba-coba yang paling penting kan jadi kan ini tuh sebenarnya kita ngebagi ini itu hasil dari sesuatu di sini. Nah,
Iya.
kita melihatnya dari situ. Nah, karena sebenarnya sih kita juga bisa lihatnya si faktor integrasi ini, si integrating factor ini tuh dia pasti ada si eksponennya kan.
Iya.
Setiap kita turunin si E kan selalu ada dia E lagi kan.
Iya, ada lagi.
Nah, dari situ sebenarnya. Jadi kita masih lihat dari sini. Nah, kemungkinan berarti salah satunya ada E pangkat sesuatu yang faktor itu sama mungkin Y gitu. Hampir pasti kayak gitu.
Sampai pasti kayak gitu.
Hampir pasti.
Tapi kalau yang soal yang ini kan tadi ini sama juga kayak yang di atas. Tapi ntar takutnya kalau di kuis atau midterm itu cari produk-produknya itu nggak ada kayak teknik khusus gitu.
Nggak ada, dia emang
Coba-coba ya.
coba-coba dan ketika kita buktikan dia diturunin pasti jadinya hasilnya di atas.
Oh.
Asal kita bisa tahu itu pasti kalau diturunin hasilnya yang sebelumnya berarti udah bisa gitu. Yes.
Separable itu. Iya.